Hello again. So, what happened just recently is we wrote down what it means for a sequence to converge. Namely, we wrote down saying that the limit of a sequence is equal to some number L means for every epsilon bigger than 0, there exists some big N such that for all little n in the natural numbers, if little n is bigger than big N, then the absolute value of the difference between a sub n and L must be less than epsilon. And that's the definition of the limit. So that means if you need to prove if some statement about some limit having some value, there's what you need to prove. So let's try to do that. So here's a first one. Let's try to prove that 3 minus n divided by n converges to -1. And I'm going to do a lot of scratch work for this, for all of these. All right, so there's what we need to prove. So I'm just going to write that down first. So our goal is going to be 3 minus n all over n, copying down that exactly. The claim is it converges to -1 minus -1 is less than epsilon. That's our goal. So let's just straight up try to figure out what this is. Right, so this is like fancified scratch work in that I actually want you to be able to follow it, but it is still just scratch work. So let's just expand that out and see what happens. Let's see if it's 3 over n minus n over n. N can't be 0 because it's a natural number. Minus minus 1 is plus 1. That looks like that's 3 over n. Everything inside's positive. Aha, aha, aha. So this is the thing that we wanted to conclude. Let's just see how big that little n needs to be. Sorry, there was a fly on my shoulder. So let's just take that and solve it for n. So 3 over epsilon, maybe I'll try to make my 3 more 3-ish, should be less than n. And so that kind of gives us our choice of big N. If little n is bigger than this value, then probably the same logic should hold. And while we check, let's actually just try to write it down. So let's try to prove this. Yeah, there's the statement we need to prove up there, though. So we need to prove something for every epsilon bigger than 0. So let's consider any epsilon bigger than 0. Let's let big N be anything that we want, but we actually already know what we want it to be. Let's take big N to be 3 divided by epsilon. Let's consider any little n in the natural numbers and assume little n is bigger than this big N. All right, good. So now let's go through the work that we did on the previous page. Then absolute value of a sub n minus -1 is equal to the absolute value of 3 minus n over n minus -1 is equal to the absolute value of 3 over n minus 1 plus 1 equals 3 over n, since 3 and n are both bigger than 0. Right? The absolute value can go away. Well, but hey, thus, absolute value of a sub n minus -1 is equal to 3 over n. And see, little n is bigger than big N. Little n is bigger than big N, so this must be less than 3 over big N, since little n is bigger than big N. But now we can make use of our choice of big N by our choice of big N, then absolute value of a sub n minus negative 1, the thing we want to show is small, is less than 3 over big N, is equal to 3 over epsilon. Hey look, that's just epsilon, which is exactly what we want. Absolute value of a sub n minus negative 1 is less than epsilon. Therefore, for all epsilon bigger than 0, there exists some big N such that for all little n bigger than big N, absolute value of a sub n minus negative 1 is less than epsilon, and so a sub n converges to negative 1. And that's the way an epsilon n proof will just look. You'll consider any epsilon. You'll figure out a choice of big N either in advance, or you'll figure out what it is as you write the proof. You'll consider any little n in the natural number, that's bigger than big N, and you'll conclude that the absolute value of a sub n minus 1 is less than epsilon. That'll prove that a sub n itself converges to negative 1. So I think what I'm going to do here is I'm going to upload several videos in rapid succession. So I'm going to hit pause and stop the recording and start a new video.